Welcome on stage, Martin.
Okay, thank you, Kasia. Good. Okay, because obviously I'm working blind now. Yeah. So Kasia, please interrupt me if when I get close to the 20 minutes. Just I tend to talk and sometimes a little bit go over the time, and I don't want to do that today. So thanks for the invitation. I'd like to present a little bit about what Neotech is doing on some 3D printed electronics, real and emerging applications. So the agenda is pretty simple. One slide on the company overview. That's for people that don't know who we are. I'll talk a little bit about how we go towards the 3D printed electronics, what the processes we use, how we do this, and then I'll get into the meat of it. Really just to showcase some of the applications that are ongoing, and then have one slide at the end with a summary. So Neotech, we're based here in Nuremberg, south of Germany. We're specialist machine tool manufacturers, only for 3D print electronics, and we've been pioneering this work. We started back in 2009. We built our first system in 2010. We had our first volume system, prototypes, the 45X system, patented system there, built in 2012, and we've been active across a wide range of industries, and I'll show you some of those activities in the following slides. So I guess we already have a few presentations about 3D printed electronics. I just wanted to give you my take on this. I see 3D printed electronics as being the addition of printed electronics functionality, sometimes or often in combination with classical surface mount devices, either onto or into structural components. So there are two basic process routes we have here. We have the left-hand side of the picture there, which is a classic MID, so molded interconnect device, or now called mechatronic integrated device, where you have a structure produced by a traditional production technique, injection molding, casting, forging, composites, whatever. And you put the electronics on the outer surfaces with the SMDs. And then we have the more, the fully additive route, where you actually print the mechanical structure. And as you build, you add your chips, resistors, whatever, with the circuitry, and you have the electronics inside and outside. So I'll cover both of those in a little bit more detail later.
Can you hear me? Can I ask you to?
Sorry, go ahead.
There's a little bar on your screen. Can you press the minimize sign next to it?
Oh, sharing the screen. Okay, apologies.
Oh,
yeah, I have.
Now.
Okay, is that better now?
Yeah, it is better. It works.
Okay, perfect. Apologies. Okay. So, benefits of 3D printed electronics. I won't go into too much detail. There are three main headings here. The design flexibility, obviously going from 2D into 3D space, gives you that design flexibility, allows you to add functionality, allows you to add intelligence and dumb mechanical components. The economics, really, the benefits depend on the application, but they stem from the reduced parts count, the materials efficiency, having shorter process chains, and also more automated manufacture. And then a very big topic and a very important topic now is sort of the sustainability and some of the strategic aspects about reducing the materials mix, having additive versus subtractive manufacture, reducing waste, reducing the amount of chemicals and other things that are involved in the production. And also longer term, simplifying the automation and potentially also simplify and automate recycling, and then also bringing things onshore, maybe back to Europe, back to the USA, for example. So there are various some macro trends that are really driving the technology adoption. Obviously, sustainability, electromobility. If you think about automotive, switching from fossil fuels to electronics, industry 4.0, Internet of Things. The idea of onshoring. So there are various trends that help combine with these benefits to drive the adoption. And I personally fully expect 3D printed electronics to mirror the growth of classical additive manufacture. We'll have a long build-up phase, and then we will get to a point where we will get some very rapid growth as things move to production. So I mentioned the process chains. So what I want to do now is really focus on the actual applications, looking at this route one, so the classical mechatronics, printing on an existing structure, and then also a few words about fully additive manufacture. So how do we get to these systems? We've seen various applications and systems today. What we do is we work in a free way using 5-axis range of motion. We use CNC motion due to the accuracy and the repeatability, path accuracy. We have worked with 6-axis robots previously. So we have that system with various vision capabilities in there, tool calibration. You have to know where your tools sit relative to your part and everything that you're trying to do. We have our own dedicated CAD/CAM software. And then what you do is you